Hey folks, this lecture we're going to talk about the different kinds of AI that you see out there today. You might have heard a couple of different terms associated with the idea of artificial intelligence. There's so many: deep learning, machine learning, neural networks, Bayesian programming, genetic algorithms. There's just more every single year. I need to mute notifications. Doesn't matter. But what you need to know as a designer, day to day, isn't what every piece of AI out there can do. What you need to know is, what can AI do? What can't it do? What are the different kinds, and intuitively, how do they work? Because that is going to help you understand how to work with it. Well, I happen to think that there's 6 broad categories for what modern AI systems do, that if you think about it this way, will help you understand what kind of context you're working in. I'm going to give you an example for each of these and hopefully help you understand what are some of the strengths and weaknesses of each of these approaches. So the 6 are predict, personalize, assist, arrange, move, and make, with some dramatic license taken to make the letters line up. A prediction system simply puts different stimuli into categories or answers something about them. So given this, is it this one or this one? Or given this thing, is it a high number or a low number? Here's an example. IBM Watson was trained on a whole bunch of images of moles, some of which were cancerous, some of which were melanomas, and was able to tell with better accuracy than the average dermatologist whether a mole was cancerous. It could do it by looking at all these different things, the shape, the color, the asymmetry, and it was able to beat a dermatologist. Of course, it was able to beat a dermatologist after being trained on millions and millions of images, and more importantly, labeled images. Someone, engineers at IBM, trained this algorithm on answered questions. And that's the key to most prediction tasks. You need to know the answer, whether you're predicting the amount that a house is going to sell for, whether you're predicting whether something is cancer, whether you're predicting whether someone is going to default on their loan, or whether a credit card transaction was fraudulent. These are all questions that you, the algorithm, has seen the answer to many, many times in the past. So, of course, the weakness of predictive approaches is that you need a ton of labeled data, and the question must be phrased in such a way that there is a simple answer. So we move then on to personalization. I think everybody has encountered examples of personalization. They're incredibly common in media contexts. So here is an example of Spotify's Discover Weekly playlist, which will show you a bunch of new music that you haven't listened to, often from artists that you haven't listened to, that it believes match your tastes. Before you can take a look too long at the kinds of wacky electronica that I like listening to, I'm going to move that back to a picture of me. Netflix does this as well, Spotify does it, YouTube does it. You're probably looking at me, there's probably a whole bunch of recommendations over here somewhere that tell you what to watch next. All of these platforms are looking to keep your eyeballs on them as long as possible so that they can serve you ads or get you to pay for your next month's subscription in some cases. And this is done by algorithms. The personalization algorithms have really taken over our lives. We are all exposed to content that goes through an AI filter, or something that I would call an AI filter. See that last video for the discussion about whether something is intelligent or not. But these do a pretty good job of serving us up more things that match our preferences. And in some case, like that one on Spotify, they even do a pretty good job of helping us expand our preferences. Although I'll note that most of them don't really do that. Most of them want you to be predictable. Most of them want to just serve you more of the same. If they can get you locked in, then they'll just give you more and more of that. They'll always be able to get more content. Predictable people are profitable people, but that's a different lecture. The weakness of these personalization algorithms is the same as for prediction. You need to have a lot of data. You need to have either a lot of data about whatever items you're recommending or about the people who are recommending them to. Entirely new people or entirely new items tend to struggle with. So the third one is AI assistants. And I think this is the category that most people associate with artificial intelligence these days, because they're the ones that live in our phones or live in our home speakers that we directly interact with as if they were an AI. This is the closest interface-wise to things like Eliza and Shurdlu from 50 years ago. All of these different devices operate on different platforms, and they all really boil down to the same kind of thing. They help you liaise with other services. Other than the incredibly complex speech processing algorithms that are in these to understand what it is that you actually asked for, beyond that, they pretty much just try and do a thing for you. Like, hey, it looks like you're trying to understand the weather. It's Clippy, if anyone remembers Clippy, but just packaged in a much, much nicer package. And then there's arranging. This one's a little bit more technical, but AI can be used to help put things that exist in very complicated spaces simply in a plane or any other flat space that we can navigate. Here is a project from a really long time ago, actually, that maps a lot of common fonts into a landscape, a kind of artificial landscape where similar fonts are close together. You can see all the serif fonts over one side and all the sans serif fonts, all the kind of block letter fonts and all the scripty fonts have all been put together. But then if you look more locally, you can see that very, very similar kind of Helvetica style fonts are all together, whereas the more kind of Roman ones are off to another side. I actually don't know that much about typography, so I'll stop trying to pretend I do. These things can be used to help you debug your work, to help visualize information, to take complex data and place them into a human, understandable set of relationships. The disadvantage here is that you need to understand what similar means. Like you need to say, okay, we're going to look at all these different attributes, and distance in this abstract space is now what makes my things similar, or how people use them is what makes them similar. You have to choose, in some sense, what makes two things alike, and for many domains, that's very far from easy to do. And then we come to moving. Moving, I use a very abstract category so that I can get that and the next one to start with the same letter. Please excuse me for that. You could just as easily say doing. The obvious example here is robots, but I'd like to show an example of something else where the system is moving things, even though not technically literally. Does anyone remember when AIs beat the world champion at Go? This is Lee Sedol, who is, I think, the world champion Go player. Go is a lot more complex a game than chess for machines to play because of something called the branching factor, which just breaks down to how many moves are possible at every time. In chess, your pieces all start on the board and you can only move them to legal new places. In Go, you can place new stones anywhere at any time. Most possible places to place stones are a terrible idea, but in principle you could place them anywhere and then your opponent could place a return stone anywhere, and as a result it's much, much harder to brute force that search to check every possible move, just because there's many more options. There's millions and millions and trillions more options. But in 2016, AlphaGo was able to AlphaGo is an algorithm made by DeepMind, a company owned by Google. AlphaGo was able to beat Lee Sedol, and it did so in a really fascinating way. This is from an article Wired wrote about that match. There's a particular move that AlphaGo took, and then Lee Sedol called for a break immediately. He saw the computer make this move, and then he called for a break. It took nearly 15 minutes to actually come up with a response. And a commentator who was himself a famous Go player said, "This is not a human move. I've never seen someone play like that. It was beautiful. It was surprising." And isn't that something different, right? The idea that humans could be surprised by machines. It wasn't playing robotically. It was playing creatively. It was certainly playing surprisingly. And digging into what creative versus surprising mean turns out to be a complicated question. Because AlphaGo knew that a human would be unlikely to make that move. One of the things it could do is estimate how likely a human grandmaster would be to play that particular move, and it estimated that that move would have a 1 in 1,000 chance of a human playing it, 0.1%. But it decided to take it anyway because it knew that it could lead to a future positive board state. It had learnt by playing against itself to outperform the human grandmaster. It had initially learnt by watching humans play at a very high level, but then it could play against itself and outperform them to the point where it would confidently take a move that none of the humans it had trained on originally would ever have taken by themselves. And that seems like a revolution, right? But actually, if you remember back to that chess game that Garry Kasparov played against IBM in 1997, Kasparov ended up accusing IBM of cheating. He said that they had to have had a human behind the scenes making those moves. He said it was a fake. He said it was a mechanical Turk situation because there were a couple of moves that he said no computer would ever choose to play. There were a couple of moves there that IBM made, that IBM Watson made, that never would, sorry, not IBM Watson, that's their new branding, Deep Blue at the time, that Deep Blue made, that a human never would have made. Deep Blue didn't have anywhere near the complexity of AlphaGo. It couldn't have assessed the capacity of humans to make that move. But it made them. Maybe it was a bug. Who knows? Maybe it just lucked out. It made them, and it surprised Kasparov. We don't know why it was surprising. It certainly reached the point where it would surprise a grandmaster. And that, I think, leads us neatly on to the last category. Can machines make things? You may have seen this by now, but have a look at these two beautiful people. These aren't pictures of some celebrity that you've never heard of. These don't exist. These were invented out of whole cloth, pixel by a neural network, an algorithm that was trained by some folks at NVIDIA, the graphic card manufacturer. Now, they definitely have a certain look, though, right? They're definitely Hollywood celebrity, although that guy might be kind of celebrity footballer. This algorithm was trained on pictures of Hollywood celebrities. That was a very popular data set for a long time, the celebrity attributes data set. Since then, there have been algorithms trained on much more diverse sets of faces that can express the full range of human facial expressions and human facial structures. But these are pretty realistic looking, and they're not a perfect match for any celebrity. They are whole cloth inventions. Are they creative? Did the machine imagine them? Does it have the capacity to surprise, to create, to imagine, to dream, to originate? Here's another one. You can, with OpenAI's GPT-3, which is a very, very powerful text generator, would be the easiest way to describe it. You can use it to make a quiz for your 8th grade science class. These questions were generated by GPT-3. GPT-3 read through the lesson plan and then automatically generated a 3-question quiz. And with this little app, it was dumped into a JavaScript form. And then OpenAI's GPT-3 can be used to check the answers. How does a fan work? You got it right. How does the moon rise in the sky? You got it right. What makes a car move? Well, that's not quite right. You got that one wrong. OpenAI just, I keep saying OpenAI's GPT-3. GPT-3 can be used to check whether these answers seem reasonable. The only thing that's missing here is students using GPT-3 to generate the answers to their quiz, and then it just could go in a cycle. You could make the quiz, you could mark the quiz, you could take the quiz, and no one would have to do any work. It'd be perfect. But this gives you an idea of how close we are to creating content that people could engage with. We're almost at the point of creating YouTube videos like this one, right? We're almost at the point of creating educational content. Are we going to put folks like me out of a job? I mean, maybe. But the fundamental limitation of all these systems remains the same. They require truly gargantuan amounts of data, and they can only learn from things they have been given. They can learn to mimic things if they're given complex data, or they can learn to answer questions if they've seen the question answered many times before. They can learn to reason about worlds if those worlds are so precisely specified that there's no ambiguity what they're referring to. Or they can learn to resolve ambiguity only if they were given the answer many, many millions of times. Is this intelligence, or is it very, very fast if statements? Well, like I said in the last video, I don't really know. But the things that we can do with it have changed the world and will continue to do so. I'll see you in class.